This content is brought to you by Mazunder Academy.
Hello everyone. Today in this session we will see how can we construct frequency distribution for a given data set in R. So first of all, for a raw data we will see how to construct the frequency distribution table. Then we will see how can we find out the cumulative frequency. Then we will find the corresponding probability value for each data in this distribution, and then finally finding cumulative probability distribution f of x. One more point I want to clear here, that actually this classical probability match question in R programming we are not able to do easily, because one of the package prob, which was very powerful package, I was using this, and all of a sudden R removed that package, and because of removal of that package, many functions that I have used for finding probabilities in the questions like roll of a die 3 times, find the probability of something like this kind of question, or coin is tossed 3 times or 4 times, find the probability of getting 2 heads, 3 heads, like this kind of question actually we are easily able to do because of the prop package. But unfortunately right now this prop package is not available with us, so somehow we are doing some of the probability questions here. But in the next lecture I will show you other form of probabilities and the distributions like binomial distribution, Poisson distribution, then normal distribution. These all things we can do. I will demonstrate it in my subsequent lectures. So let us start the demonstration. Here I am going to use cylinder data in empty car data set in R. So write a R program to find the following. Construct a frequency distribution table of the cylinder data. Then display the cumulative frequency. Then display the corresponding probability value and display the cumulative distribution function CDF or capital F of x. So frequency distribution table, if you forget, I can remind you, like we have some data here, say for example 4, 7, 3, these are the data, and these are the repetitions of the data. How many times that a particular data 4 repeated in this data set. So 4 repeated 6 times, 7 repeated 11 times, 3 repeated 5 times. So when you will write the data in this manner, then it is called frequency distribution of that particular data. So first of all we have to see the data set, view empty cars, and if you run it we can see the empty cars data set mpg cyl. So we are using this cyl data, cylinder data, for construction of this frequency distribution table. Now immediately we have to attach empty cars, and as I said earlier, if we attach, then what will be the benefit? We can access the column directly without using any dollars. So you run this attach, these are some of the warnings and some of the information, so doesn't matter for us. After attach, we can first construct the frequency distribution table. There is a function called table. If we apply this table function in cylinder data and run, we can see the frequency distribution and the categories or the levels of the data in cylinder. What are the different levels? 4, 6 and 8, and 4 appeared 11 times, 6 appeared 7 times, 8 appeared 14 times. Let us store this information in a variable called t. So we run it again. Now t is created. We can see here in the right hand side, t is created. It's a table. Now We don't want our data should be like this. We want it should be a frequency distribution, like it should be x here and frequency here. That is data here and frequency here, like this. So this is nothing but a data frame. So we can convert this table into a data frame. Say df is the data frame variable where the data frame is stored for future use. Data.frame is the function that will create the data frame, and where is the data? Your data is stored in T. So we applied data.frame function over T, which will convert the table data into a data frame. And now if I print, then we will see my data frame. So let us run this all. We can see the output. So cylinder data here, and if you don't like cylinder data, how can we change it? You can do one thing. You can just copy the data in a variable, say x. So if you store this cylinder data in a variable x, in that case all the data will be stored in variable x, and you can pass x here. In that case x will appear here. So let me run it. So we can see x is my data 4, 6 and 8, and frequency is 11, 7 and 14. So this is the answer for A. Now next, display cumulative frequency. So cumulative frequency, if you remember what is cumulative frequency? Cumulative frequency, if we just CF is the short form of cumulative frequency, and it will be how we do it in theory. The first frequency will come here, then this frequency will add with the next frequency, and so it will be 6 plus 11, that is 17. Then 17 plus 5 will be 22. So that will be the cumulative frequency, and we want to add this cumulative frequency column with the previous data frame. So we will do this all in practical. Now how can we find out this cumulative summation? There is a function called cumSum, cumulative summation. And where is your data? Your data is available inside the data frame df, and the frequency available here in this second column. So cumSum df is the data set or the data frame inside which your table of data is available, and then put the dollar, second column is the frequency. So it will find out the cumulative summation of all the frequencies. And suppose you store it in a variable called CF. CF is the variable where the cumulative summation of all the frequencies of this data frame is stored. And now we need to print. So in the existing data frame, again we can apply data.frame. Original data frame is available in df, and the new column is CF. These two should be added together and new data frame will be created. And let's store this data frame in a variable called CDF, and then we will print CDF. So if we run one by one, we can see the new data frame is x468, frequency 11, 7, 14, then CF is 11, 18 and 32. So this is question B. Next, if we see question available in C, display the corresponding probability values. Now let me take you to that theory. Now if I want to write the probability value, what will be the probability of 4? Probability of 4 will be how many 4 available? 6 number of times divided by total how many data here? Total is 22 data. So this will be the probability of 4. Similarly, if you want to find out probability of 7, then it will be total 11 times 7 appearing and out of 22. And similarly, if you want to find out the probability of 3, then it will be 5 times 3 is appearing out of 22. This will be the probability for the corresponding data 4, 7 and 3. So let's do it in practical. We are going to find probabilities. So we can write prob is a variable which I am going to create, where I will store my all these probabilities. So my frequencies available in the data frame df column frequency, and this all individual frequencies should be divided by the total data. So how can you count the total data? Length is the function which will count the total data. So if I run it, prob is created, and if I just want to print, so you write the prob variable and print it, so you will get the probability here 0.3437, 0.21, like this, 43750. So total is 1. So I want to display my result like as I show here. So that means I want to add this column with the previous data frame. So similar method, we will apply data.frame function on the previous data frame. And what is the previous data frame? CDF. CDF is the data frame CDF, and the new column which will be added is prob. Whatever name you will give here, the same name should be passed here. And if you store this in a variable for future use, let us store this output of this data frame to a variable, say PDF, probability data frame. And now we have to print. So just print, and the variable is PDF. So if we run this all information, we will see the data frame is framing X, frequency, cumulative frequency, then probability. Okay, so this is the question C. Next and the last question is D, where we need to find out the cumulative distribution of the probabilities. Like, as you know, this capital F of X, it will be cumulative sum of the probabilities. So first will be 6 divided by 22. Maybe it will appear in practical as a decimal form. Then next one will be 6 plus 11, that is 17 divided by 22. And next one will be 17 plus 5, 22 divided by 22 equal to 1. So this will be the cumulative distribution function of the probabilities, that is capital F of X. As you know, cum sum is the function that will find out the cumulative summation. And where is the probability? The probability is available in any one of them. We can use PDF, then $prob. So I want to make a data frame as before, data.frame, and first one should be previous data frame, that is PDF is the data frame, comma, the new column is CDF. Let me store this information to a variable, say final or something. You can give any name, and finally you will print. If you run this information, you will get your complete distribution. So frequency distribution, then frequencies, then cumulative frequencies, then probabilities, then probability distribution function CDF. So that's all for this lecture. Thank you so much.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.